Okay, chapter 3.3, taking the derivative of inverse functions. So it says, recall, a function's inverse is found by swapping the input and output values, so swapping the x and y values. Okay. The notation may be a little confusing because we know that x to the negative 1 power is the same as saying 1 over x, but f to the negative 1 power of x does not mean 1 over f. Instead, this means that wherever our x and y values are originally, we are going to flip them when we find the inverse. Okay. Here are three ways to say the same thing. So g of x is the inverse of f of x. Or we could say g of x is equal to f inverse x. Okay, same thing. Or that the composition of f of g of x and g of f of x are both equal to x, which tells them that they are the inverse of each other. Another way we could think of this is if f of a is equal to b, so we plug in a number into the function f and get b, then the inverse of b is a. So if we plug in a value and get b in our original function, that means if we plug in b into our inverse function, we should get a. Okay, derivative of an inverse function. So when you think of the rule here, in order to find the derivative of the inverse, this is going to be the same as 1 over f prime of y, which means that the inverse of x is equal to y, then f of y is equal to x. Okay, notice that the derivative of the inverse is not 1 over f prime of x, but instead 1 over f prime of y. So in the example below, it says let g of x equal f inverse of x. So we know that the derivative g of x is equal to 1 over f prime of y based off the definition. And then looking at the table, we're able to identify what f of 1, f of 2, f of 3, and f of 4 are by looking at this part of the table. So for example, f of 1 is equal to 3, f of 2 is equal to 1, f of 3 is equal to negative 5, and f of 4 is equal to 0. Well, if we were to translate this into g of x, we know that we would have to flip the x and y values, which means that g of 3 is equal to 1, g of 1 is equal to 2, g of negative 5 is equal to 3, and g of 0 is equal to 4. Okay, so if I were to color code these, notice that the x became the y in each of these. And then the y became the x. So we're same concept of switching the x and y values. So for the first example, it says, what is the value of g prime of 1? Well, we know that g prime of x is equal to 1 over f prime of y. So g prime of 1 is going to be equal to 1 over f prime of 2. Okay, so where we're looking is right here. Okay, if we plug in 1, okay, we're going to get 2. Well, we know that f prime of 2, based off of the next part of the table over here, f prime of 2 is negative 2, so this is equal to negative 1 over 2. It says write an equation for the line tangent to the inverse of f at x equals 1. Well, we already know that our slope is negative 1/2, and then our point of x comma y is going to be 1 comma 2. Okay. And that is, again, looking right here. Okay. Because we're trying to find the inverse of f, which we know is going to be equivalent to us looking at g, or g prime of x. So then we use y minus y1 equals mx minus x1, and we get y minus 2 is equal to negative 1/2 x minus 1, and that would be our answer. Okay, number 3 says, let g be differentiable functions such that g of 12 is equal to 4, g of 3 is equal to 6, and g prime of 12 is equal to negative 5, and g prime of 3 is equal to negative 2. The function h is differentiable, and h of x is equal to the inverse g of x for all x. What is the value of h prime of 6? So the first thing we have to do is find h of 6. Well, since h is the inverse of g, we know that we need to find one of the original g functions that are equal to 6. So that means we're looking at these two right here. And this one is the only one equal to 6. So that means h of 6 is equal to 3. And then we know that h prime of x is equal to 1 over g prime of y. So if we're trying to find h prime of 6, we know that's the same as finding 1 over g prime of 3. And g prime of 3 is negative 2, so this is negative 1/2. Okay, number 4 says if f of x is equal to 3x cubed plus 1, and g is the inverse function of f, what is the value of g prime of 25? Okay. Well, if we're trying to find the inverse function, that means we are taking this function, y is equal to 3x cubed plus 1, and swapping x and y. So x is equal to 3y cubed plus 1. Okay. Then we need to find g prime of 25. Well, g prime of 25 is telling us that this 25 is our x value. So I'm going to plug in 25 for x. Okay, so this is 25 is equal to 3y cubed plus 1, and then I'm going to solve for y. So this is 24 is equal to 3y cubed, 8 is equal to y cubed, the cube root of 8 is 2, so y is equal to 2, which means g prime of 25 is equal to 2, which is our y value. Okay. Now, in order to find g prime of 25, I know that this is going to be the same as doing 1 over f prime of 2. Well, since f of x is equal to 3x squared plus 1, f prime of x is equal to 9x squared. Sorry, that was supposed to be a cubed. Okay, 9x squared. Which means in order to find f prime of 2, this is 9 times 2 squared, which is 36. So that means g prime of 25 is equal to 1 over 36, and that is our answer.